There is another type of inequalities which includes the modulus, or the sign used for absolute values, and they are called absolute value inequalities. Check out how they are solved here in Mathematics of Engineering. Recalling what absolute value is, it is a term or expression bounded by two bars which we know as modulus. The absolute value of a number will always be positive. Take the absolute value of -5, which is 5, and also the absolute value of +5 is also 5. When we talk about equations, there are linear and nonlinear. Likewise, there are also absolute value inequalities which are linear and nonlinear. Since our discussion is inequalities, let's start with linear absolute value inequalities. Its standard form is the absolute value of ax plus b, and the inequality symbol bridges the binomial with c. Like solving any other type of inequality, the procedure aims to zero out the constant c. When c is linked with 0, solutions to the inequalities can be figured out without further computation. The first case is if c is less than 0. There is no solution. Here is an example to prove it. If we have the absolute value of 2x minus 1, and this is increased by 4, everything is less than 4, simplify the inequality by eliminating 4 to have the absolute value of 2x minus 1 is less than 0. If 2x minus 1 is less than 0, this means that the whole term is a negative integer, and it is in contrast with the description of absolute value that it always results to positive integers. Thus, this inequality doesn't have any solution. Another case is when c is less than or equal to 0. This is closely related to the first case, but since it has an added feature of c equal to 0, this gives one solution. For example, with -3 plus the absolute value of x plus 1 is less than or equal to -3. Simplify it to have the absolute value of x plus 1 is less than or equal to 0. So the absolute value can have a solution for x as -1, to have the whole term equated to 0. The third case has c as greater than or equal to 0. This case has solutions of real numbers. Say the absolute value of x minus 4 is greater than or equal to 0. So starting from x is equal to 0, moving to 1, 2, 3, and so on, there can be probable solutions to the inequality. The last case is when c is greater than 0. The solution will be all real numbers connected with a union. If we have the absolute value of x plus 6 is greater than 0, we can set x plus 6 to be unequal to 0, which results to x as any number except -6. So we can have all negative integers and positive integers as long as it is not -6. What is the procedure of solving absolute value inequalities? First, simplify the whole expression to reduce terms. If the absolute value is isolated, there are two methods to interpret the solution. One is working with two different inequalities and having them joined by and. The other method is solving the inequality by converting the absolute value to compound inequality. After having values of x, you may need to verify the range, and you can use graphing to easily visualize the condition, after which you can write the ranges in interval notation. What is the solution of 3 multiplied by the absolute value of 4x less 1 is less than or equal to 9? We solve this inequality using the separate inequality method. We first simplify the whole inequality by dividing it by 3. So we get the absolute value of 4x minus 1 is less than or equal to 3. Eliminate the absolute value by placing the constants as positive and negative, where the latter constant will also be connected by the opposite operation. So we get 4x minus 1 is less than or equal to 3, and the other is 4x less 1 is greater than or equal to negative 3. Isolate 4x by adding 1 on both sides, resulting to 4x is less than or equal to 4. Then divide both again by 4 to get x, which is less than or equal to 1. On the other side, we do the same procedure of isolating 4x first by adding 1 on both sides, and we get 4x is greater than or equal to negative 2. Then divide both by 4 to get x is greater than or equal to negative 1/2. Having the answers, we can summarize them as x is less than or equal to 1 and x is greater than or equal to negative 1/2. We're going to compute the same inequality of 3 multiplied by the absolute value of 4x minus 1 is less than or equal to 9 with the second method using compound inequality. The first simplification is to isolate the whole absolute value by dividing everything by 3. So we get the absolute value of 4x minus 1 is less than or equal to 3. From this point, we can take the expression and place the two constants of positive and negative 3 placed on both ends of the binomial 4x minus 1. But this time, we don't need to flip inequality symbols. So now we have negative 3 is less than or equal to 4x minus 1 is less than or equal to 3. We can move on by simplifying the middle term by adding 1. So we get negative 2 is less than or equal to 4x is less than or equal to 4. We can have x by dividing all by 4. So we are down to negative 1/2 is less than or equal to x is less than or equal to 1. Take a look at the second example. It has negative 5 multiplied by the absolute value of 2x plus 2, and it is reduced by 3, all of which is greater than or equal to negative 13. Simplify the whole inequality by adding 3 on both ends to have negative 5 multiplied by the absolute value of 2x plus 2 is greater than or equal to negative 10. Then again, we can divide both sides by negative 5 to get the absolute value of 2x plus 2 is less than or equal to 2. You might be wondering why we flip the inequality sign. Again, this is because we divided the inequality by a negative integer. In the end method, the inequality can be grouped into the original symbol and the opposite. So we get 2x plus 2 is less than or equal to 2 using the original symbol. And 2x plus 2 is greater than or equal to negative 2 for the opposite. Working on the original inequality, take away 2 from both sides to have 2x is less than or equal to 0. And dividing both sides by 2 to isolate x gives x is less than or equal to 0. This is our first value. From the opposite inequality, do the same by taking away 2 to have 2x is greater than or equal to negative 4. and divide them by 2 to get x is greater than or equal to negative 2. These are the two values of x. Thus we have x is less than or equal to 0 and x is greater than or equal to negative 2. With the same example, negative 5 multiplied by the absolute value of 2x plus 2, and this is less than 3, is greater than or equal to negative 13. Recall that this is simplified as the absolute value of 2x plus 2 is less than or equal to 2. Instead of working in two groups from this inequality, we convert it by placing 2 on both sides, one as positive and the other as negative. Isolate 2x by taking away 2 on all sides, so we get negative 4 is less than or equal to 2x is less than or equal to 0. Then we can finally isolate x by dividing the inequality by 2. So we end up with negative 2 is less than or equal to x, which is again less than or equal to 0. So, if we integrate the example's interval notation, we can start with the number line, marking negative 2 and 0. Recall again that with the equal sign with the inequality, we use brackets. Thus, the interval notation is negative 2 and 0, both enclosed with brackets. Another example using the two methods is 3 multiplied with the absolute value of half of x plus 2, then plus 6 is less than 15. All constants are multiples of 3. So we simplify by dividing 3 to have the absolute value of 1/2 of x plus 2 is less than 5. Take out 2 from the left side of the inequality. Then we get the absolute value of 1/2 x plus 2 is less than 3. Having the simplest inequality, we can now divide it to opposites, taking the original half of x plus 2 is less than 3, and the other is 1/2 of x plus 2 is greater than negative 3. Now, we focus on the original inequality. Subtract 2 on both sides to have 1/2 of x is less than 1. Then multiply both sides by 2 to have x is less than 2. The opposite inequality would also be simplified by subtracting 2 to have 1/2 x is greater than negative 5. Multiply the resulting inequality by 2, and it yields x is greater than negative 10. So x is taken as less than 2 and greater than negative 10. With the compound inequality method, the procedure still starts by simplifying the inequality, and that is through dividing it by 3, which gives the absolute value of half of x plus 2 is less than 5. Then, subtract 2 on both sides to have the absolute value of 1/2 x plus 2 is less than 3. Next is to convert the inequality to compound inequality by placing the inequality with positive and negative 3. Simplification starts by eliminating the constant in the middle term. So we deduct 2 to have negative 5 is less than 1/2 x is less than 1. We can isolate x by multiplying everything by 2, and we get negative 10 is less than x is less than 2. When this is interpreted using a number line, the marks are placed in negative 10 and positive 2, and both are with open notation. So the interval notation is taken as negative 10 and 2, both enclosed in parentheses.